Let's look at solving this first order differential equation. Alright, here we'd have to use separating the variables to solve it. So I want you to write it down, pause the video, and go ahead and solve it. Okay, you finished? What did you get for your solution? Alright, so let's see what happens now. Suppose we multiply both sides by y, divide by y squared minus 1, dy by dx equals, and we have over here, it would be 1 over x, but then we multiply by dx. Alright. Now, we now find the integral. We integral y over y squared minus 1 dy equals integral of 1 over x dx. Alright, now, let's look at the left hand side. Going to concentrate on the left hand side for now. What we have is the integral of y over y squared minus 1 dy. Let's try substitution. Let u be equal to y squared minus 1. Then du by dy would be equal to, well, it's 2y. And here, this thing running along. Dy would be equal to du over 2y. So what we have is the integral of y over u is y squared minus 1. So this is y squared minus 1. So it's over u times dy, but dy is du over 2y. Y would cancel y. So what we have, let's put the 2 around here. So it's half integral of 1 over u du, which is ln, which is half ln u. And then this would be half ln y squared minus 1. Alright. Now, what we did was, let's put the y squared minus 1 in a bracket. What we did was integrate the left hand side. So we have half ln y squared minus 1. Alright, now that is equal to 1 over x dx. So we're showing both the left hand, the integral of 1 over x dx. So that we're showing both sides now. Alright. So here we already integrated the left hand side, and this would be half ln y squared minus 1 equals, okay, now this would be ln x, and we put plus c. We did not put a plus c earlier, because if we put a plus c here and a plus c on the right, or we'd have to use two different letters, because we're not going to assume that it's the same, the constant is the same on both sides. If we put a plus, say, a on the left and a plus c on the right, you could always put them together and say c minus a, and we get a different letter b, and put a plus b on the right. So let's just put the plus c on the left alone. Okay, we could fix this up a bit. This is ln y squared minus 1 to the power of a half. You have to remember your rules of logarithms. All right. So this one is like you're saying ln, say 2 ln 5 is the same as ln 5 squared, which is the same as ln 25. We could try it in our calculator. We find ln 5 and multiply by 2. So what we have is ln 5 equals that. Multiply by 2. You get 3.2188 and so on and so forth. Now let's find ln 25 equal. Same thing. Alright? You have to remember your rules of, or your laws of logarithms. Alright? So here now, this could be written, well, c could be ln of another number. So let's say it is ln x plus ln d. Alright? So this is ln y squared minus 1 to the power of a half equals ln dx. Multiply them. Okay, look at this now. E raised to the power of ln y squared minus 1 to the half is equal to e raised to the power of ln dx. So this now, the e raised to the power of ln, this is the anti-logarithm and this is the logarithm, so they cancel out each other, right? So what we have is y squared minus 1 to the half is equal to dx. Now, if we raise each to the power of 2, square each, what you would get is y squared minus 1 is equal to d squared x squared. But d squared could be another constant, it's something else. D squared is another constant. So what we have is y squared minus 1 equals, call it ex squared. So there we go. And we could even write it as y squared equals ex squared plus 1 if you want. Alright, so that's your solution.